This is Mr. Ward, and I'm going to do a short video key for Do Now 13.3 for Friday. So here's the deal. We've got the vertical angle theorem to prove, which is Theorem 17. That's that's section 2.8 in the chapter. But we don't have that achievement unlocked yet, so we got to prove it. So we got to prove it without using the vertical angle theorem. So the vertical angle theorem certainly will say that angle HFE is congruent to GFJ, and so I'm going to go ahead and draw on here. So this angle and this angle, I can mark. I know that I will be able to prove these because I'm familiar with the vertical angle theorem. We've probably all heard about it back in 6th grade at some point. So how do we prove this? Well, here's how we prove it. We start by noticing that we have straight lines here. That's a straight line, okay? And and this is also a straight line, okay? So this is a straight line. And so what we can say is that this angle, HFE, is plus. So HFE is supplementary to HFG. So here's what we say. Angle HFE is not sus, to HFG. And angle GFJ is sup to angle HFG as well. By the way, you could have used EFJ for this. It doesn't matter which one you use. You just want to pick one that you're using for each of them. Okay, so I just moved my screen down. Let me move it back. Make that an angle. Okay, so so HFE is supplementary to HFG, and GFJ is supplemental to angle HFG as well. If two angles are supplementary to the same angle, they are congruent. Okay, that's an earlier theorem, but angles that are supplementary to the same angle are congruent angles. So there you have the proof, and that proves, ultimately, that's how we can prove the vertical angle theorem, which will state that these opposite angles are congruent. There's going to be a reference to a concept called opposite rays. So like ray FH and ray FJ are called opposite rays. They share the same endpoint and go in opposite directions from each other, making a straight angle. And then EF, ray EF and EG are called opposite rays. So just take note of that language. That will be a little picky detail that's defined in 2.8. Now let's prove that GH is congruent to JK. So here's GH and here's JK, and we know that GJ, okay, so GJ, we know that this line segment here and this line segment here are congruent because of given. Okay, so based on that given, what we can say is two congruent, so GH is GJ minus HJ, and JK is HK minus HJ. So by subtraction, we can prove that GH is congruent to JK because if you subtract the same segment from congruent segments, you get congruent differences. Okay. Now, number 3, we want to find the complement. So this one is one of those ones that trips people up sometimes because it's all wordy. So I find it useful to draw something like this. So we have complement. So that means we have a right angle and it's split somehow. Okay, I'm going to call that a right angle. Okay, boop, boop. Okay, I've called it a right angle. And somehow there's some sort of ray coming out and breaking it up into two angles. We don't know that it's bisected, so I'm just saying it's split up. Okay, so we know that the complement of an angle is 24 more than twice the measure of the angle. So that language is saying, so 24 more is plus 24. And if the first angle was x, then it's 24 more than twice x. So 24 more than twice x is the complement to x. And since it's a complement, x plus that equals 90 degrees. And so we just solve for x. Okay, so we start off by subtracting. We can combine like terms. We get 3x and then plus 24. We can do it that way. Or we could subtract 24 from both sides. So then I'll subtract 24 from both sides. So 3x is going to equal 66. And then we'll divide both sides by 3, and x will equal 22, if I haven't done any calculation errors. So now we've got the complement. So the complement of an angle. So we want to know what the complement is. The complement is this part that is 2x plus 24. So 2 times 22 plus 24 is going to equal 44 plus 24, which is going to equal 68. And 68 plus 22 checks out. Always a good idea afterward to say, okay, 22 plus 68, and that does equal 90. So those are complements of each other. Okay, so I hope that clarifies that one. The bottom line is we were given this information that said we have a complement. Okay, there's a complement. We're going to call that x. And the complement of x is 24 more, so that's the plus 24, then twice the measure of x. Okay, measure of our angle. Okay, now here we've got this triangle with triangles. We know that BC plus BE equals AD. Okay, we also know that BE is equal to EF, so I can label the congruence. Okay, so BE is congruent to EF. We're supposed to prove that BC plus EF equals AD. Okay, we're given that AD, this whole thing here, okay, we're given that BC plus BE, okay, equals AD. Okay, we're given that information, and we are given that BE and EF are congruent. So we're trying to prove that BC plus EF equals AD. We know that BC plus BE equals AD. So we're going to use substitution on this one. So because BE and EF are congruent, okay, we can substitute EF for BE in the addition equation. Okay, so we have BC plus BE equals AD. Substitute EF for BE, and we have BC plus EF also equals AD by substitution. Okay. All right, so there's other stuff to deal with, so please address that. If there is anything you still need to share with me up through Chapter 1, locus stuff, constructions, the evacuation of the Blargian bomb from Königsberg, any of that stuff you need to make sure I have, please make sure I have it. All right, I'm going to stop sharing, and I hope this video helped.